All right, let's dive in. Today, we're going to tackle this paper that's made some serious waves. Attention is all you need.
Yeah, quite a title, right?
Pretty bold. It basically says, hey, this new transformer thing we came up with, it can change how you do machine translation just using attention. So ready to unpack all this.
Absolutely. To get why the transformer is so important, we got to look back a bit, you know? Like, what were the limitations of the models before, the RNNs, those recurrent neural networks?
Right, RNNs.
Y-
They were like the stars of language processing for ages, but they had this bottleneck.
Yeah, exactly. Think about it like reading a book, but only one word at a time. Can you imagine trying to follow the plot like that?
Talk about a slow read.
Haha, yeah. RNNs worked kind of like that, processing info sequentially, so slow for long sentences and really hard to parallelize.
So basically, they couldn't see the whole picture, just tiny bits at a time.
Exactly, and that limited how efficiently they could learn.
Gotcha. So how does this transformer, transform things?
Well, it ditches that whole sequential thing entirely. It uses this attention idea. The model can focus on the most relevant parts of the input all at once to make its predictions.
So it's like instead of analyzing everything in order, it just jumps to what matters most. Sounds powerful. But how does this attention thing actually work? Get technical on us.
Imagine searching for info in a huge document. Your brain naturally filters out the noise.
Right. You zero in on what you need.
Right. Attention in machine learning is similar. The model weighs different parts of the input, giving more importance to what's likely to make the prediction accurate.
Like a built-in highlighter for the key parts of a sentence.
Exactly. And they took this a step further with self-attention. The transformer can analyze relationships between words in a sentence, all at the same time.
So context and meaning become way clearer than with RNNs.
Exactly. Like, take the sentence, the animal didn't cross the street because it was too tired. Self-attention helps figure out that it refers to the animal, not the street, by looking at the relationships between all the words.
Ah, those tricky pronouns. So how does self-attention actually do that? This is where things get really complex, right?
It does. At its heart, the transformer uses an encoder-decoder structure. The encoder reads and understands. The decoder uses that to generate the output.
Encoder understands, decoder generates. Got it. But where does this self-attention magic fit in?
The magic is in those layers of multi-head attention in both the encoder and decoder. Like, imagine a team of experts, each looking at a different part of a sentence, then sharing their insights for a complete understanding.
Oh, that's interesting. So it's like different lenses, each highlighting different aspects of the sentence's meaning.
Exactly. Within the encoder, self-attention analyzes relationships between all the words in the input sentence. And in the decoder, it does the same for the output, so the generated text makes sense. Then there's encoder-decoder attention, where the decoder looks back at the encoded info to keep the output accurate and relevant.
So not just understanding single words, but how they relate to each other. Across sentences, too. That's a big jump from RNNs.
Huge leap. But there's another key part. Positional encodings.
Okay, positional encodings. What do we need those?
Remember, the transformer doesn't process sequentially, so it needs a way to know word order, something RNNs got just from going one word at a time. Positional encodings add a unique vector to each word, showing its place in the sentence.
Like giving each word its own address in the sentence so the model doesn't get lost.
Exactly. They use sine and cosine functions to make these vectors. This lets the model handle sentences longer than it saw during training, unlike RNNs, which struggled with that.
That's really clever. So we've got multi-head attention, positional encodings, all very technical. But what's the actual advantage of using a transformer? This must lead to some serious performance boost, right?
Oh, absolutely. First, training is way faster because it processes the whole sequence at once, unlike RNNs, which have to go step by step. This is huge when you're dealing with tons of data and complex models.
It's like reading an entire book at once versus one word at a time.
Exactly. Second, the transformer handles much longer sequences without performance tanking. It doesn't have to remember everything like an RNN. It can just jump to any point thanks to self-attention.
Like having a larger working memory.
Yeah, exactly. And because of this, it often performs much better on tasks like machine translation. Remember the title, Attention is All You Need. They got state-of-the-art results on English to German and English to French translations, beating even models that combined different architectures.
They put their money where their mouth is.
Yeah.
But is translation all it can do? Or can this architecture be applied to other language tasks?
Great question. It's not a one-trick pony. They also used it for English constituency parsing, which is analyzing the grammatical structure of a sentence. And get this, it did great, even with limited training data.
So it can generalize to other language stuff and learn efficiently. Impressive. But let's bring it back to our listener for a second. Why should you care about this research? What's the real-world impact of all this?
That's key. This research is pushing what AI can do with language. It's already out there in the real world. The transformer is being used in stuff like improving Google search, powering chatbots, and those virtual assistants we all use.
So it's not just a theory. It's actively shaping how we use tech. That's pretty amazing. But we've covered a lot. Can you summarize those key technical takeaways about the transformer?
Here's the core. The transformer uses only attention mechanisms to process language. It trains much faster, handles longer sequences, and often performs way better, especially in translation.
Attention is key. And what's exciting is that it can go beyond just translation. It has the potential to change lots of areas of AI that deal with language. But I got to remember that even groundbreaking tech has its challenges, right?
Exactly. No model is perfect. Understanding those limitations is important as we see what it can really do. We'll dig into those and more in the next part of our deep dive.
That's a perfect cliffhanger. We've explored the transformer's inner workings, and now it's time to tackle those complexities and potential challenges. Join us for part 2, where we'll unpack the limitations of the transformer and ponder what this all means for the future of AI.
So ready to dive back in. I'm really interested to unpack some of these technical hurdles, even with all the progress the transformer has made.
Yeah, you said it before, no model is perfect. What limitations should we be aware of with the transformer? Where do those clever mechanisms we talked about hit a snag?
One limitation, kind of ironic, comes from its strength, handling those long sequences. While it's great at it, it gets computationally expensive as the input gets longer. Remember how attention needs to analyze every pair of words.
So longer sentences mean way more comparisons, more work for the model.
Exactly. So researchers are working on more efficient attention, like sparse attention. The model focuses on the most important pairs, not everything.
So instead of analyzing every connection, it prioritizes, like a super efficient detective, just finding the key clues.
Exactly. Another challenge is in training. The transformer, with all its bells and whistles, needs massive amounts of data and computing power to train well. This is a hurdle for smaller research teams who might not have those resources.
It's like needing a huge engine for a race car.
Yeah,
All the tech is there, but it can't reach its full potential.
exactly. And this raises questions about access to this tech so more people can contribute to the field. Another area where the transformer has limitations is with certain language things, like idioms or cultural references. Those rely on implicit context.
So even though it's great at grammar and relationships between words, it struggles with those subtle, ambiguous bits of language, like knowing the literal meaning of a word, but not the deeper cultural stuff.
Great analogy. And this shows that language models are still evolving. The transformer has brought big progress, but there's room for improvement.
Yeah, language is complex. Replicating that in a machine is tough. But even with limitations, the transformer has really sparked innovation. Researchers are building on it, finding new applications, and pushing what's possible.
Absolutely. It's a catalyst, not the final product. We talked about making it more computationally efficient. There's also work on hybrid models, combining the transformer with other architectures. Maybe one's better at those nuanced language bits we discussed.
So it's not just improving the transformer, but integrating it with other models, each specializing in something different, like building a team of experts for the challenge of understanding language.
Exactly. And as research progresses, we'll see even more innovative and unexpected applications, changing how we interact with tech and with each other. One exciting area is conversational AI.
You mean like chatbots and virtual assistants that can hold natural conversations, almost like with a real person?
Exactly. The transformer can understand context and generate coherent text perfect for that. Imagine a virtual assistant that not only answers questions but also understands what you mean, gives personalized recommendations, even jokes around a bit.
Like a personal assistant who gets you and anticipates your needs. Way beyond those robotic chatbots we have now.
Absolutely. But it's not just about human-like tech. The transformer could break down communication barriers between people.
Imagine language not being a barrier anymore. People from different cultures understanding each other easily, sharing ideas and stories.
Right. The transformer's progress in machine translation is making this happen.
That's a powerful vision, language not being a barrier to collaboration and understanding. But with any powerful tech, there are challenges to consider as the transformer becomes more widespread.
Very true. We need to think about the societal impact and use it ethically. Bias is a big concern. Like any machine learning model, the transformer learns from data. If that data has biases, the model might keep them going, even make them worse.
So it could magnify societal inequalities.
Exactly. Tackling bias in AI is super important. Developers need to be really careful about the training data and keep checking the model's outputs to ensure fairness and avoid unintended consequences.
So it's not enough to just build a fancy model. It has to align with our values and make society better.
Exactly. This needs collaboration. People from computer science, ethics, social sciences, all working together to guide AI development in a responsible and beneficial way.
It shows that the future of AI isn't just about the tech. It's about human values and using it ethically for the good of everyone.
Well said. The future of AI, like language itself, is always changing. We're shaping it together, and the choices we make today will determine what our world looks like tomorrow.
And that brings us to the end of this part of our deep dive. We've explored the transformers' technical limitations, the exciting possibilities, and started thinking about the ethical side of things.
It's been a great discussion. Your questions and insights have made this really engaging.
Thanks. And to our listeners, thank you for joining us. We hope this deep dive has gotten you thinking about the power of AI, what the transformer can do, and the impact it could have on our future.
Remember, the future isn't something that just happens. We create it. Stay curious, ask questions, and keep exploring. The world of AI is huge and always changing, and we're excited to keep learning with you.
And we're back for the final part of our deep dive into the transformer. We've gone pretty deep, explored how it works, what it's good at, where it struggles, and even touched on some ethics. Now, what about the future? What's next for this architecture, and how might it change AI and even the world?
Oh, the future of the transformer is wide open, full of possibilities. Technically, we'll see a push for more efficiency, making it less computationally demanding so it can handle even bigger, more complex tasks without needing a supercomputer.
Making it more accessible, basically, and even more powerful. How are they trying to do that? We talked about sparse attention. Anything else?
Yeah, there's this really cool area, adaptive computation. Imagine the transformer, but it can adjust how much computational effort it uses depending on the input. Simple sentence, easy mode. Complex language, full power.
So it's becoming more context-aware, adapting to the task. Clever.
Right, and this opens up more ambitious applications. Real-time translation, processing and translating speech on the fly, or summarizing huge amounts of text to something short and informative. Lots of potential.
It's like the transformer is becoming this ultimate language expert, handling all sorts of tasks. But zooming out a bit, how do you see it impacting AI as a whole? Any big shifts happening?
The transformer has definitely changed things. AI can now understand and reason about language in ways we couldn't have imagined before. It's inspiring a ton of innovation, with researchers building on it to create even more specialized and powerful models.
Like it's the foundation for a whole new generation of AI.
Perfect analogy. And this changes how we interact with technology, even with each other. Think about a world without language barriers. We could communicate with anyone, anywhere, access information and ideas from all over. The transformer's progress in translation is already making this a reality.
That's a powerful image, a world where ideas can flow freely, more collaboration, understanding, maybe even empathy. But like we've talked about, with great power comes responsibility. What challenges and ethical things should we be thinking about as the transformer becomes more a part of our lives?
You're right. Bias is a huge one. Like all machine learning, the transformer learns from data. If that data has biases, the model could unknowingly continue those biases, and that could lead to unfair or discriminatory results.
It could make existing inequalities even worse.
Exactly. We have to address bias in AI. We need to be super careful with the training data and keep checking the model's outputs to make sure things are fair and we avoid unintended consequences.
It's not enough to just build amazing technology. We have to build it in a way that aligns with our values and helps create a better world.
Absolutely. And this needs people from all sorts of fields, computer science, ethics, social sciences, working together to guide AI development in a responsible way.
It's a good reminder that the future of AI isn't just about the tech itself. It's about human values and making sure it benefits everyone.
Couldn't have said it better. The future of AI, like language itself, keeps changing. We're shaping it together, and the choices we make now will determine the world we live in tomorrow.
And on that note of shared responsibility and the huge possibilities ahead, we've reached the end of our deep dive into the transformer. It's been amazing to explore this groundbreaking architecture, its potential to change things, and the ethical challenges we face.
It's been fantastic discussing this with you. Your questions were really insightful, and I've enjoyed this deep dive a lot.
Likewise. And to our listeners, thank you for joining us on this journey. We hope you've learned something new, maybe gotten a bit curious about the power of AI, and started thinking about the future the Transformer might bring.
Remember, the future isn't set in stone. We're creating it. Stay curious. Keep asking those tough questions and keep exploring. The world of AI is vast and always changing, and we're excited to keep learning with you.
Well said. Until next time, everyone, keep those minds active and those imaginations going. The journey of discovery never ends.